Hello people, welcome back to my channel. So in the previous video we saw about underfitting and overfitting in decision trees, and also we saw what was decision trees and why it is used in machine learning. So today's video is all regarding the generalization error, means how you can estimate some error in decision trees. So today's video will be all regarding the generalization error. So let's begin. So what do you mean by generalization error? Means it's an error which is there in the decision tree, and it's an overall generalized error, not about one particular error on test data or training data. So generalization error, in the basic essence, it means that the expected prediction error over an independent test data. Means however the learning algorithm have the knowledge about the training data, it will have no knowledge about the test data. Means whenever you train a model, your learning algorithm, that is LA, will have access to the training data but does not have access to the test data. So we try to predict the error which is there on the test data and not on the training data. So there we come across the term generalization error. So our main aim in generalization error is to minimize the generalization error or to lower it as much as possible. So generalization error estimate in decision tree is done with the help of two techniques. So we have generalization error GE estimate. So very first technique is by optimistic error estimate, or it is also called as resubstitution error estimate. So this means that the error which is generally seen on the decision trees, that we try to focus, and thus we get the resubstitution error or the optimistic error. Next type of error is the pessimistic error estimate. And so it deals mainly with the model complexity. So how complex is your model, based upon that you have the pessimistic error estimate, and this basically deals with an penalty parameter or a hyperparameter. So I'll explain with the help of an example. So for that, just consider this decision tree. So these are the number of nodes and these are the links which it has, that is a directed edges, and then we have some of the leaf nodes. So at the base level, so first of all we have 1 2 3 4 5 6 7, so we have 7 leaf nodes. So we just estimate, that is, let k be the number of leaf nodes, and in this case it is equal to 7. Now at each of the leaf node we have two classes basically. So we have one class that is positive, and we have another class, that is class 1 and class 2. One class is positive and one class is negative. So what this figure what basically means that plus, that is positively this instance has classified 3 correct, and it has classified one instance negatively as negative. So ideally it should be the positive class, so it's incorrectly classified one instance to be negative. Similarly here, one instance was negatively classified. Here all the instances were properly classified or correctly classified as negative. Here one instance was classified as negative. So whatever is the smallest number, you go with that. Here you have all the instances correctly classified as to be positive class, that is 3 instances. Here we have one instance to be incorrectly classified as negative, and here all the instances have been correctly classified as the negative class. So how do you compute or how do you estimate the optimistic error? So it's generally given by E of t, that is the error on the tree, entire tree. So it's given by the number of error in total. So here you have, that is one error, again you have one error, you have another one error. Here you don't have any error because it's correctly classified to be negative. Here it's correctly classified to be positive, that is all 3 instances are correctly classified to be positive. Here you have one instance to be negative, and here you have all correctly classified as negative. So in total you have 1, 2, 3, 4. So 4 is the error on this tree, and the total number of instances, that is 3 plus 1 4, and 4 plus 3 7, 9, 10, 11, 12 and 15, 15 plus 1 16, 19 and 24. So you get this estimate. So this value comes out to be 0.167. So this is our optimistic error estimate or the resubstitution error estimate. Now there is one concept. So you have seen, that is the model overfitting. So why usually this happens? Because your model is very complex. This is the reason why your model is going to overfit. So there is one principle, it's called as the principle of parsimony, or it is also called as Occam's razor. Yeah, it's Occam's razor. And what this basically states that given two models, that is you have two models, two different models having the same generalization error, then the simpler model is preferred over the complex. So it's simple like that. So if your model is too complex, you don't go with that, instead you go with the simpler model. Now based upon this induction of this model complexity, you have this pessimistic error estimate. So it is given by EG of t. So the formula is simple. So it has this optimistic error estimate, that is E of t, and plus you have the leaf, that is the number of leaf nodes you have in this entire decision tree, and it's multiplied by some parameter, that is it's omega t. Now this is called as the penalty parameter. So it's mainly used in order to just penalize the decision tree for making the error, and it's divided by the total number of instances. So we go with this. So we have 4 from here and plus, and this omega t, that is penalty parameter, is decided by the user itself. So it can be, say for example, 0.5, and k we have here 7. So this number can be anything. So it is user defined, so you need not worry about from where this 0.5 came. So it's 0.5 is user defined, or you can have any number of penalty parameter for penalizing a decision tree, and it's 7 multiplied by, that is 0.5, and so you have 24. So when you just compute this, you get this as 4 plus 3.5, that is 7.5 divided by 24. So you have these two estimates for estimating the generalization error in decision tree. So you have another thing also in this, that is the reduced error pruning, that comes in pruning part, that is pre-pruning and post-pruning. So that will be our next video. So hope you guys enjoyed this video and got educated from this video. Please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.